Hey yo, it's your boy PhisyIzzy back at it again with another physics video where physics is fun! Today we're gonna be testing out a roller coaster because that's physics. How are we gonna do it? With those Hot Wheels tracks and our trusty number 6 screen pool ball. And so, here's the plan, here's the layout, here's what we're thinking, right? We're gonna wanna start it up here with our green trusty pool ball and our Hot Wheels track. We're gonna have it come down over here around this area. We're gonna have a loop-de-loop. We're gonna go shoo, and then it's gonna come over here, go over a little hump, right? Because that's always cool, you know. And then we're gonna go swerve a little bit over here through the pillar of the railing. Come over here, around this pillar, and then it's gonna go over there, and it'll have some fun over there. You'll see, you'll see.
Now, the concept of the roller coaster is pretty simple. We have a hill, into the loop, and into the bump. So this hill is around 0.81 meters high. The loop is 0.22 meters. And this bump here is 0.12 meters. Alright, so up here at the top of the hill is where there's going to be the most potential energy. Right there. And at the bottom of the hill, right here, so there's going to be the most kinetic energy. Now, on this hill, the entirety of the potential energy is going to be transferred to kinetic energy, and since energy is always conserved, the max potential energy is equal to the max kinetic energy. So on the hill, the potential energy is turned into kinetic energy. That. Now, as we get into this loop here, the kinetic energy is going to start turning back into potential energy, but since the loop is not as high as the top of the hill, it's not going to reach maximum potential energy. Like that. And then as it goes down the other side of the loop, potential energy is going to be turned back into kinetic energy until it reaches the bump, in which it's going to turn back into potential energy, and then back into kinetic energy on the other side of the hill. Now, for the point that we have to find kinetic energy for, we're going to use this point right here at the top of the bump. And I have our equations for kinetic energy and for potential energy. So the potential energy at this point, since the mass of the ball is 0.15 kilograms, potential energy equals 0.15 kilograms times the acceleration due to gravity, which is 10 meters per second squared, and times the height, which we said already was 0.12 meters, and all of that multiplied together get you the potential energy of the point. Now I'm gonna finish this, then do this equation, and I'll meet back up with you when I have the answers. Alright, got these two equations done. So the potential energy at this point is equal to 0.8 joules, and the kinetic energy is equal to 0.0148 joules. Now, if you add these two numbers together, you get 0.1948 joules, which is equal to the total mechanical energy, give or take a little bit. Now, we're going to do the acceleration and the velocity of the ball between the point at the bottom of the loop here to the top of the hill. So this segment right here, find an average velocity and acceleration. So I'm going to do that. I'll catch up back with you when I'm done. Alright, got these two equations done. The velocity of the average velocity of the ball traveling from here to here is roughly 0.823 meters per second, which makes sense because it's a pool ball, it's not going very fast. And the acceleration is negative 1.4686 meters per second squared, which also makes sense since the ball is going uphill, it's slowing down, so acceleration is negative. And that's all the math.
Alright, Fizzers, we just finished building this roller coaster, and I don't know about you, but I cannot wait to show you guys this roller coaster. This is gonna be sick. Alright, let's get going. Alright, Fizzers, it's time to see if physics really does work, and to see if this roller coaster can take this ball all the way to the end. You ready? Because I sure am. Let's go! Alright, Fizzers, that was another episode of PhisyIzzy. You guys saw how that roller coaster worked. It took the ball all the way to bottom. You got anything to say?
Yeah, we saw that the potential energy turned into kinetic energy as it went down the ramp, but the total mechanical energy remained the same because energy is conserved.
That was just what I was gonna say, just what I was thinking, and you know what? That's a great way to put it. Alright. Thank you so much for tuning in to another episode of PhisyIzzy, and don't forget to like, subscribe, and comment your favorite theme park horror movie. Alright, let's go! See you in the next one! Woo! Physics is fun!